Good evening, everyone. We are going to start our third podcast here of Chapter 3, and we're going to be taking a look at using the periodic table. Now, this is going to be very important, this little lecture, in terms of parts of the periodic table, but we're going to keep coming back and back and back again to the periodic table, that you've got to know the certain parts of it because it gives you hints as to the next concept that we're going to be covering, how it helps you. For instance, next chapter we're going to be talking about how to name compounds. Well, it really helps you with the naming system if you know that this side is the metals and here are the nonmetals. It just helps you understand that you need to do ionic bonding, or if you have two nonmetals, you do molecular bonding and so forth. So the first thing is we're going to label up and down. We are going to say that every one of these columns that you see up and down are called either groups or families. Most of the time you will hear me say the word families, but sorry, I can't write this. You have to understand that you need to be able to use those words interchangeably. So up and down are called groups or family. And then as we go across on the periodic chart, across this way is going in the same row is called a period or simply a row. And Dmitry Mendeleev put a lot of thought in taking a look at different trends within our families and with our periods to see why elements should be placed where they are. So I'd like you to go ahead and label family A, family B, and then go way over here to family C and family D. These are the four that we are going to focus on right now as we take a look at these. So if I take a look at family A are called the alkali metals, and they are very reactive. You are never going to find them in free nature. And so these are the alkali metals, and you might take a look at a few of them and say, oh, I recognize hydrogen, and I think I've seen lithium before, and potassium I know is in bananas. Well, yes, you do have potassium in bananas, but it is found in a compound. So they are not found in free nature. You can't be trucking along the countryside with a pick or an axe or a shovel and expect to find these. When you do, they will be in a compound form. So column B is going to look very similar. These are called the alkaline metals. And the alkaline metals, just put them in alphabetical order. If I do that, alkali, alkaline, so family 1, family 2. The alkaline metals are very similar to the alkali metals. They are also not found in free nature, and the chemical reaction activity also increases as you go down the family. We'll be talking a lot about that in the future. Then if I go all the way across over here, these are called the nonmetals. These are going to be our halogens. So if I take a look at family C, these are called halogens, and they are also called salt producers. And you will see that you have chlorides and bromides, some common salts, iodides, and they also, if you think of halogens, you might think of light and light bulbs. And then we have family D, which is going to be our noble gases, and we will refer to our noble gases and their stability very often. So these are our noble gases, and they have full outer shells. They're very, very stable. We will be comparing all these other elements very often to family 8 or 16, 18, depending upon how we classify it. So the very last family on the periodic chart. Now, this whole half on the left-hand side that you need to understand all the way over to this zigzag line that you see over here, these are all called the metals. Now, you can also see that there's this part here. We have alkaline metals, and then we have this part that kind of drops through the chart. They are the ones that are going to have some weird properties that we're going to have to take a look and discuss. And these are the ones that fall right here in this little box. And these are called our transition metals. Now, if you think of the word transition, you are moving from one thing to another. You're transitioning through. And that's exactly what is happening here. I have the alkali metals that are not found in free nature. Many of these are. And then we're getting over to our metalloids, which are going to be these right here, and then our nonmetals. So first, let's take a look at our metalloids, as I just mentioned. And if we put an X through the ones that are actually the metalloids, metalloids. What is going on with my pen here? It must be how I'm holding it. All of these X's here are called our metalloids on both sides of our zigzag line. And then we have these over here that are called our nonmetals. Okay, so nonmetals. And then right here are called our metalloids. So these X's are metalloids. And it should make sense to you that I have my metals over here, I have my nonmetals over here. So it should make sense to you that if I get to a metalloid, it has properties of some metallic properties and some non-metallic properties. And it's a mixture of both. We will be taking a look at this in class with a small activity that we're going to be doing back in lab. And then down here, these are called our rare earth elements. So the rare earth elements are the lanthanides and the actinides. These are the ones that have been found later, and they're just not as common. One that is, you'll see down here, is you'll have uranium. We will be talking about that a lot when we get to our nuclear chapter. So this is the basis of our periodic chart. This is where we're going to start. And again, we just need to start learning about these regions. Hopefully that is not new to you. Okay, active reading questions again. Make sure that you take a look at those. And now we're going to take a look at our natural state of elements. Most elements are reactive, as we just talked about, alkali and alkali metals, found combined with other elements to form compounds. Some are less reactive, gold and silver and platinum, you know that. All right, so if we continue to take a look how they naturally exist, we have things called diatomic molecules. A molecule meaning that I have more than one atom there. Diatomic, dia means two. So if you look at my examples here, I have nitrogen, 2 atoms. I have oxygen, 2 atoms. So nitrogen gas is not ever just going to be plain old N. Oxygen is never going to be plain old O in the gaseous form. It's far, far too reactive. It naturally exists in our atmosphere, which we know that nitrogen exists as 78%, and oxygen is going to be 21%. And they exist as diatomic molecules. So it's always N2 when we say nitrogen. It's always O2 when we say oxygen. So here's some examples. There are 7 of them. And if you take a look at where they are on the periodic chart, we'll talk about this in class, that it starts with nitrogen, add hydrogen, starts with nitrogen, and forms a 7. And I guess I can show you, I do have a periodic chart on here, don't you? I kind of forgot that we used it in our last lecture. But if I take a look here, and I clear my ink on this slide, I think I can do that. And if I take a look here, its hydrogen is diatomic, and then it starts with atomic number 7 and makes a 7. So all of these are diatomic. So you are able to see, if you had to ever memorize this, it would be hydrogen, starts with 7 and makes a 7. There's my crazy little 7 there. So this is how they naturally exist in nature. That's how we find them, as diatomic molecules. All right, let me get back to where we were. We were on this screen right here, and so you can see the different, at 25 degrees Celsius is room temperature, and you can see that this is how they exist. All right, now if we take a look at allotropes, and we are actually going to discuss this one in class because I have a couple models and I have some other clips that we are going to be taking a look at. So we are going to skip right along this slide and we are going to go to the last couple comments here. Ions in their compounds. When I say the word ion, you need to think that something is charged. It has a charge. Atoms can form ions by gaining or losing electrons. Now, when you think of an atom, remember it has the same number of protons are equal to the number of electrons. It makes it neutral. and they can gain or lose electrons, and that is how it's going to be charged. Metals tend to lose one or more electrons to form positive ions called cations. Well, how does that happen? So here if I take a look at magnesium, and if I look in the periodic chart, its atomic number is 12. So that means as a neutral atom, as we just talked about here, I have to have 12 protons, which is what is in my nucleus, and 12 electrons, and they are equal. Now, magnesium wants to lose 2 electrons to become stable. So how it does this, the nucleus cannot change. If that changes, I no longer have magnesium. So I still have my 12 protons here, but now I have 10 electrons. Well, if I have 12 positives and I have 10 negatives, you guessed it, I have a +2 charge. And that is called a cation. So you can see that they wrote the symbol Mg with a +2 charge. Now, if I go in the other direction and add an electron like the nonmetals want to do, and remember nonmetals are on the right-hand side of the periodic chart, they tend to gain 1 or more electrons. So here again, if I take a look at chlorine, I have 17 protons and I have 17 electrons. Well, that better be the same if I have a neutral substance. Well, what happens for it to become a chloride ion? Remember, ion means that it's charged. I have a -1, -1 here, because I found out that I have 18 electrons, I have 17 protons. Well, if I do the math, that is overall a -1 charge. You don't need to really worry about this. They have IDE ending. We're going to do the naming in the next chapter. So if I take a look at this, you guys can see that ions in the periodic table. We talked about Mendeleev and how he put things all together. Well, all of these elements you can see have a +1 charge. All of these have a +2 charge. Then we have our transition metals with the cations changed from time to time. And then I have a +3 right here with all of these ions. And these are gaining electrons, -2, -1. Now, these are right along with our nonmetals, so that is why they vary in charge depending upon what element we are talking about. So if we just take a look at this first one here, and then I'm going to challenge you to try to figure out the rest of them. I see that when I cut and pasted this, this did not copy very well. But if we take a look, pause. Okay, sorry about that. Had a little interruption there. Keep in mind that sometimes I'm sitting here at home and I have my children around. All right, so if I take a look at this, I want you to take a look at oxygen. And it's saying that it is gained 2 electrons. You have to remember electrons are negative. Well, in order for oxygen to be oxygen, I look at the atomic chart, look at the periodic chart, and the protons for oxygen are 8 because it has atomic number 8. Then if I round this, a mass number is 16 minus 8, so I also have 8 neutrons. Well, if it was neutral, I would have 8 electrons. But here I can see that it's gained 2 electrons, so now I have 10. Well, what does that ion mean then? That I have an oxygen with a -2 charge because it has gained 2 electrons. Well, let's do one in the opposite. You can see I have aluminum, Al, with a +3 charge. Well, what does that mean? So my element over here is aluminum. You can go ahead and write that in. And has it gained or lost electrons? Well, if it has a positive charge, it has lost electrons. And I know that seems backwards, but you got to get that in your head because it's the electrons that are moving around. So if it has a +3 charge, it lost those 3 negatives. So it lost my 3 electrons. This has nothing to do with the number of protons, so its atomic number is 13. I do my subtraction. Mass number subtract atomic number will give me 14. My electrons now, if it was neutral, it would have 13 electrons. However, it lost 3, so now I only have 10 electrons. So go ahead and see if you can figure out the rest of this chart. We are going to work together some more on this in class and see if you can figure out what the ion charges are. All right, that's it for this chapter. You guys can see the very last slide has just a summary of everything that I've already talked about, and you are now going to need to complete these book questions. Have an excellent night, and I will see you soon in class.